Hello everyone, my name is Radifah Kabir. I'm from the Department of Food Engineering and Technology. I'm presently in 6th semester BTech. I would like to thank Dr. Lakshmikant Badwaik for giving me this wonderful opportunity to present a video on the topic Principles of HACCP. I hope this video proves to be helpful for all of you. HACCP stands for Hazard Analysis and Critical Control Points. Hazard refers to the food contamination or spoilage. Analysis refers to the finding out of the source. Critical means the level of danger. Control refers to the remedial actions. Point refers to the stage for corrective action. What is HACCP? HACCP is a management system in which food safety is addressed through the analysis and control of biological, chemical, and physical hazards from raw material production, procurement, and handling to manufacturing, distribution, and consumption of the finished product. HACCP is designed for use in all segments of the food industry, from growing, harvesting, processing, manufacturing, distributing, and merchandising to preparing food for consumption. Food safety systems based on the HACCP principles have been successfully applied in food processing plants, retail food stores, and food service operations. The 7 principles of HACCP have been universally accepted by government agencies, trade associations, and the food industry around the world. Now let's discuss the principles of HACCP. There are 7 principles of HACCP, namely, Principle 1, conduct a hazard analysis. Principle 2, determine the critical control points. Principle 3, establish critical limits. Principle 4, establish monitoring procedures. Principle 5, establish corrective actions. Principle 6, establish verification procedures. Principle 7, establish record keeping and documentation procedures. Now, one by one, we shall be discussing the different principles. The first principle is conduct a hazard analysis. The hazard analysis includes the likely occurrence of hazards and severity of their adverse health effects or effect on product quality or regularity, compliance, qualitative and or quantitative evaluation of the presence of the hazards, survival or multiplication of the microorganisms, production, persistence, or cross-contamination of toxins, chemicals, or physical agents. The hazard analysis and identification of associated control measures accomplish 3 objectives. Those hazards and associated control measures are identified. The analysis may identify needed modifications to a process or product so that product safety is further assured or improved. The analysis provides a basis for determining critical control points in Principle 2. The process of conducting a hazard analysis involves 2 stages: hazard identification and hazard evaluation. Hazard identification. This is the first stage, which can be regarded as a brainstorming session. During this stage, the HACCP team reviews the ingredients used in the product, the activities conducted at each step in the process, the equipment used, the final product, and its method of storage and distribution. The intended use and the consumers of the product can also be determined. Based on this review, the team develops a list of potential biological, chemical, or physical hazards which may be introduced, increased, or controlled at each step in the process. Now let me discuss one by one the different physical, chemical, and biological hazards. The physical hazards occur as a result of accidental contamination or cross-contamination. It can also result due to food handling. The different kinds of physical hazards are metal, glass, wood, insects, stones, soil, dirt, jewelry, hair, fingernails, plasters, personal items, bones, nuts, bolts, wire, plastic, paper, and cardboard. The different kinds of chemical hazards are cleaning chemical residues, factory contaminants, agricultural residues, food allergens, naturally occurring harmful chemicals, and industrial heavy metals. The biological hazards include bacterial, viral, and fungal contamination. Different food safety hazards. As I have already mentioned, there are biological, chemical, and physical hazards. Biological hazards include bacteria, viruses, parasites, and molds. Chemical hazards include pesticides, processing chemicals, drug residues, and allergens. Physical hazards include bones, pits, and bugs, and glass, metals, and hair. Hazard evaluation. After the list of potential hazards is assembled, stage 2, the hazard evaluation is conducted. In stage 2 of the hazard analysis, the HACCP team decides which potential hazards must be addressed in the HACCP plan. During this stage, each potential hazard is evaluated based on the severity of the potential hazard and its likely occurrence. Severity is the seriousness of the consequences of exposure to the hazard. During the evaluation of each potential hazard, the food, its method of preparation, transportation, storage, and persons likely to consume the product should be considered to determine how each of these factors may influence the likely occurrence and severity of the hazard being controlled. Upon completion of the hazard analysis, the hazards associated with each step in the production of the food should be listed along with any measures that are used to control the hazards. The term control measure is used because not all hazards can be prevented, but virtually all can be controlled. More than one control measure may be required for a specific hazard. On the other hand, more than one hazard may be addressed by a specific control measure. Example, for the pasteurization of milk. For example, if a HACCP team were to conduct a hazard analysis for the production of frozen cooked beef patties, then enteric pathogens, which are Salmonella and Verotoxin producing Escherichia coli, in the raw meat would be identified as hazards. Cooking is a control measure which can be used to eliminate these hazards. What product safety devices are used to enhance consumer safety? These are metal detectors, magnets, sifters, filters, screens, thermometers, bone removal devices, dud detectors. We have taken into consideration a particular step, which is that of cooking. The potential hazards in raw meat are enteric pathogens, which are Salmonella and Verotoxigenic E. coli. The justification provided is that these enteric pathogens have been associated with outbreaks of foodborne illnesses from undercooked ground beef. The hazard to be addressed in this plan? Yes or no? Yes, the hazard should be addressed in this plan. The control measures are cooking. Now let me discuss some examples of practices that increase potential food safety hazards. Cross-contamination, storage of raw food with ready-to-eat food. Employ practices leading to cross-contamination, such as handling raw and cooked product without washing and sanitizing hands, failure to properly clean equipment, failure to adequately protect food from contamination, such as storing raw food above cooked food in refrigeration units. Improper cold storage, food stored at improper temperatures, coolers without thermometers, poor cooling practices, overloading refrigerating units, storage of food in improperly labeled containers. After that, we come to the second principle, which is determine the critical control points. A critical control point is defined as a step at which control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. The potential hazards that are reasonably likely to cause illness or injury in the absence of their control must be addressed in determining the CCPs. Examples of CCPs may include thermal processing, chilling, testing ingredients for chemical residues, product formulation control, testing products for metal contaminants. For example, A specified heat process at a given time and temperature designed to destroy a specific microbiological pathogen could be a CCP. Likewise, refrigeration of a pre-cooked food to prevent hazardous microorganisms from multiplying, or the adjustment of a food to a pH necessary to prevent toxin formation could also be a CCP. Now let's discuss an example of a CCP decision tree. The first question which is asked is, does this step involve a hazard or sufficient likelihood of occurrence and severity to warrant its control? If the answer is no, then it is not a critical control point. If the answer to the previous question is yes, then a new question is asked, which is, does a control measure for the hazard exist at this step? If the answer is no, then another question is asked, is the control at this step necessary for safety? Now, if the answer to this question, that is the control at this step necessary for safety, is yes, then the step is modified, and the product or the process can also be modified. However, if the answer to the question, is control at this step necessary for safety, no, then it is definitely not a CCP, and we should stop at this stage. However, we are returning to our original question again. Does a control measure for the hazard exist at this step? If the answer to this question is yes, then we move on to another question. Is control at this step necessary to prevent, eliminate, or reduce the risk of the hazard to the consumers? If the answer is yes, then it is definitely a CCP. If the answer is no, it is not a CCP, and we need to stop at this stage. After that, we come to the third principle, establish critical limits. A critical limit is a maximum or minimum value to which a biological, chemical, or physical parameter must be controlled at a CCP to prevent, eliminate, or reduce to an acceptable level the occurrence of a food safety hazard. A critical limit is used to distinguish between safe and unsafe operating conditions at a CCP. Each CCP will have one or more control measures to assure that the identified hazards are prevented, eliminated, or reduced to acceptable levels. Each control measure has one or more associated critical limits. Critical limits separate acceptability from unacceptability. Critical limits should be measurable, observable, able to monitor in real time, and follow critical limits in industry guidelines, codes of practice, and legislation. Others can be determined from collection of data from experiments or expert advice from specialists. Critical limits may be based upon factors such as temperature, time, physical dimensions, humidity, moisture level, water activity, pH, titrable acidity, salt concentration, available chlorine, viscosity, preservatives, sensory information such as aroma and visual appearance. For each CCP, there is at least one criterion for food safety that is to be met. An example of a criterion is a specific lethality of a cooking process, such as a 5D reduction in salmonella. An example is the cooking of beef patties. The process should be designed to ensure the production of a safe product. The hazard analysis for cooked meat patties identified enteric pathogens such as verotoxigenic E. coli, which is E. coli 0157H7 and Salmonella, as significant biological hazards. Furthermore, cooking is the step in the process at which control can be applied to reduce the enteric pathogens to an acceptable level. To ensure that an acceptable level is consistently achieved, accurate information is needed on the probable number of the pathogens in the raw patties, their heat resistance, the factors that influence the heating of the patties, and the area of the patty which heats the slowest. Collectively, this information forms the scientific basis for the critical limits that are established. Now let's talk about examples of critical limits to reduce or eliminate hazards at critical control points. Here, The critical control point taken into consideration is receiving. The critical limits for receiving are potentially hazard food at or below 40 °F, and the other one is that there is no evidence of spoilage, abuse, foreign objects, or contamination in the food. When the critical control point is chilling and cold storage, then the critical limits are: do not leave potentially hazard food at room temperature. Also, there should not be overloading or stacking of the containers. After that, we talk about food handling as the critical control point. In this case, there should be proper hand washing, there should be proper dishwashing and sanitizing techniques. Also, the cuts and scratches which are open should be covered and protected, and clean and sanitized equipments and utensils should be used. Then we talk about the critical control point, which is shipping. Potentially hazardous food at or below 40 °F. This should be the critical limit for the critical control point of shipping. After this, we come to principle 4, which is establishing monitoring procedures. The documented monitoring procedure for each CCP shall define responsibility, frequency, methods, and records to be kept. Responsibility refers to the job title of who will do the monitoring. Frequency refers to the frequency which is sufficient to ensure that the CCP is under control. Methods refer to the detailed specification or procedure, and records to be kept include action limits, critical limits, result of monitoring activity, signature of the responsible person, and verification counter signature. Monitoring is a planned sequence of observations or measurements to assess whether a CCP is under control and to produce an accurate record for future use and verification. Monitoring serves three main purposes. Firstly, monitoring is essential to food safety management because it facilitates tracking of the operation. If monitoring indicates that there is a trend towards loss of control, then action can be taken to bring the process back into control before deviation from a critical limit occurs. Secondly, monitoring is used to determine when there is loss of control and a deviation occurs at a CCP, that is, exceeding or not meeting a critical limit. When a deviation occurs, an appropriate corrective action must be taken. Third, it approves of written documentation for use in verification. Ideally, monitoring should be continuous, which is possible with many types of physical and chemical methods. For example, the temperature and time for the scheduled thermal process of low-acid canned foods is recorded continuously on temperature recording charts. If the temperature falls below the scheduled temperature or the time is insufficient as recorded on the chart, the product from the retort is retained and disposition determined as in Principle 5. Likewise, pH measurement may be performed continuously in fluids or by testing each batch before processing. When it is not possible to monitor a CCP on a continuous basis, it is necessary to establish a monitoring frequency and procedure that will be reliable enough to indicate that the CCP is under control. Most monitoring procedures need to be rapid because they relate to online, real-time processes, and there will not be time for lengthy analytical testing. Typical monitoring procedures include visual observations, sensory evaluations, chemical measurements, physical measurements, microbiological measurements. Microbiological tests are seldom effective for monitoring due to their time-consuming nature and problems with assuring detection of contaminants. Physical and chemical measurements are often preferred because they are rapid and usually more effective for assuring control of microbiological hazards. For example, the safety of pasteurized milk is based upon measurements of time and temperature of heating rather than testing the heated milk to assure the absence of surviving pathogens. So this is a table in which different hazards have been described and the temperature checks and the visual checks have been determined. The processing step is cooking in both the cases. The hazard is also the same, which is that of microbiological survival of Salmonella and Campylobacter species. The control measures are thorough cooking. Critical control points have been determined. Now, the critical limits in case of temperature check are 80 degrees Celsius for 6 seconds, and the target is 85 degrees Celsius for 6 seconds. In case of visual check, the meat should not be pink or red, and neither should the juices be. The monitoring procedures in case of temperature checks are that insert the disinfected probe thermometer to the thickest part of leg of each chicken, and in case of visual checks, we must check that each chicken is properly cooked in the thickest part of the leg and the juices are 100% clear of blood. After that, we come to the fifth principle, which is establish corrective actions. The corrective actions will differ slightly depending on which limit is breached. Where action limits are breached, corrective actions should include immediate action to re-establish control before the deviation leads to a CCP breach. There should be responsibility for corrective action. Where critical limits are breached, corrective actions should include immediate action to re-establish control, identification of all product produced since critical limit was breached, disposition of affected product, and responsibility for the corrective action. The HACCP system, Food Safety Management, is designed to identify health hazards and to establish strategies to prevent, eliminate, or reduce their occurrence. Corrective actions should include the following elements: determine and correct the cause of non-compliance, determine the disposition of non-compliant product, record the corrective actions that should have been taken. Now here we are taking into consideration the corrective actions for temperature check and visual check, and we see that they are similar. The procedure is that of cooking and the food material is meat. So let's take into consideration the steps. If critical limit is not met, then one should cook for a longer period of time and there should be repeated checks. In case of visual check, if the meat is pink or red, then the same procedure should be performed. If problem occurs due to operating procedure, then one must adapt as required, that is, increase the cooking time or increase the oven temperature. If problem occurs due to oven, then it should be repaired or replaced as necessary. If the problem is due to the staff, then the operating procedures and other processes require a lot of supervision. If one is unable to achieve critical limit, then that process should be isolated. The meat should be isolated and disposal should be arranged. After that, we come to the sixth principle, establish verification procedures. Verification is defined as those activities other than monitoring that determine the validity of the HACCP plan and that the system is operating according to the plan. As corrective actions are implemented, it is important that they are verified. Verification includes microbiological testing to confirm that CCPs are in control, shelf life validations covering both microbiological and sensory testing, physical assessments of products against specifications, reviewing internal incidents, non-conforming product records, customer complaints, withdrawals, or recalls relating to food safety, quality, or legality, internal audits of CCP monitoring and corrective action records. One aspect of verification is evaluating whether the facility's HACCP system is functioning according to the HACCP plan. An effective HACCP system requires little end product testing. Therefore, rather than relying on end product testing, firms should rely on frequent reviews of their HACCP plan. Verification that the HACCP plan is being correctly followed and review of CCP monitoring and corrective action records. Another important aspect of verification is the initial validation of the HACCP plan to determine that the plan is scientifically and technically sound, that all the hazards have been identified, and that if the hazard analysis plan is properly implemented, then these hazards will be effectively controlled. Information needed to validate the HACCP plan often include expert advice and scientific studies, in-plant observations, measurements, and evaluations. For example, validation of the cooking process for beef patties should include the scientific justification of the heating times and temperatures, which are needed to obtain an appropriate destruction of the pathogenic microorganisms, and studies to confirm that the conditions of cooking will deliver the required time and temperature to each beef patty. Verification is split into three parts: validation, verification, and review. Verification activities are carried out by individuals within a company, third-party experts, and regulatory agencies. It is important that individuals doing verification have appropriate technical expertise to perform this function. Validation. Will the HACCP plan ensure that safe food will be produced? Verification. Is the HACCP plan working? Is it producing safe food? Review. Is the HACCP plan up to date? Validation activities include challenge testing the equipment or machinery. Mathematical modeling. Verification activities include internal audits, external audits, and ensuring that prerequisites are under control. Things to be reviewed include change in raw materials supplier, change in processing system. Now we come to the last step or the last principle, which is establish record keeping and documentation procedures. Documentation should also exist to demonstrate that the HACCP plan has been effectively managed and implemented. This should also include CCP monitoring records, corrective action records, HACCP training records, and competency assessments for operators, supervisors, and managers. Evidence of HACCP management including verification schedule and records, team meeting minutes, and modification records. Generally, the records maintained for the HACCP system should include the following: a summary of the hazard analysis include the rationale for determining hazards and control measures, the HACCP plan, listing of the HACCP team and assigned responsibilities, description of the food, its distribution, intended use, and consumer, verified flow diagram, HACCP plan summary table, support documentation such as validation records, and also records that are generated during the operation of the plan. Examples of HACCP records: ingredients for which critical limits have been established, the supplier certification records documenting compliance of an ingredient with a critical limit should be maintained. Also, processor audit records verifying supplier compliance should be maintained. There should also be storage records, example time and temperature for when the ingredient storage is a CCP. Processing, storage, and distribution records. Information that establishes the efficacy of a CCP to maintain product safety. Data establishing the safe shelf life of the product if age of product can affect safety. Records indicating compliance with critical limits when packaging materials, labeling, or sealing specifications are necessary for food safety. Monitoring records and verification records. Deviation and corrective action records. Employee training records that are pertinent to CCPs and the HACCP plan. Documentation of the adequacy of the HACCP plan from a knowledgeable HACCP expert. The record of a HACCP system should include records for critical control points, establishments of limits, corrective actions, results of verification activities, and the HACCP plan including hazard analysis. To establish record-keeping procedures, plant management may develop forms to fully record corrective actions taken when deviations occur and identify employees responsible for entering monitoring data into the records and ensure that they understand their roles and responsibilities. HACCP process flow map. Let's discuss some activities and then I shall be telling you the hazards and controls associated with those activities. When the activity is purchased, then the hazards are physically, chemically, and biologically contaminated products. The controls are approved suppliers. When the activity is delivery, then the hazards are physically, chemically, and biologically contaminated products. The controls are approved suppliers, delivery vehicle inspection, visual checks of products, and date codes. When the activity is storage, the hazards are contamination and multiplication of bacteria. The controls are maintain correct temperatures and segregation of products. When the activity is preparation, then the hazards are contamination and multiplication of bacteria. The controls are separation of raw and prepared food, color coding system, clean and sanitized utensils and work areas, and minimize handling at room temperature. When the activity is cooking, the hazards are survival of microorganisms. The controls are cook thoroughly to core temperature. When the activity is service, the hazards are contamination and multiplication of bacteria. The controls are maintain the correct temperatures, use clean and sanitized utensils, and there should be minimized handling. After that, I would like to discuss HACCP in dairy industry. Here, I have mentioned the flow diagram for milk processing. The first step is that raw milk is collected and received. It is preheated at 35 to 45 degrees Celsius. Then it is filtered and clarified. After that, it is stored in tank. Then standardization is performed. After that, pasteurization is performed. Then homogenization is done. After that, packaging is performed. And then finally, cold storage is the last step. Prerequisite programs in milk processing. The prerequisite programs used in the milk processing are the sanitation programs to maintain sanitary condition in the building premise equipments to maintain a clean and hygienic environment essential for the production of highest quality and safe food products. Good manufacturing practices in the industry to control hazards. The pest control program was designed to allow no pests in the plant. This included rodents, insects, and birds. The product recall program was developed to protect customers from the probable events of product safety malfunction by eradicating all varied products from the distribution channels in the minimum time once a product recall or withdrawal is defensible and commenced for the product. Assessing food hazards. When we assess the food hazards, then we take into consideration the different processing stages and we look at the hazards associated with each stage. Receiving of raw materials. The biological hazards are bacteria, mold, and yeast. The chemical hazards are the presence of therapeutic drugs, cleaning and sanitizing agents, and mycotoxin. And the physical hazards are hair, dust, dirt, feed, manure, and flies. In case of preheating of milk, the biological hazards are bacteria, chemical hazards are antibiotics, cleaning and sanitizing agents, and mycotoxin, and the physical hazards are hair, dust, dirt, feed, manure, and flies. When filtration and clarification is the processing stage, then biological hazard is contamination with vegetative pathogens. The physical and the chemical hazards are none. When storage in tank is the processing stage, then contamination and growth of vegetative pathogens is the biological hazard. Chemical hazards include cleaning and sanitizing residues, and the physical hazards are none. When standardization is the processing stage, then contamination and growth of vegetative pathogens are the biological hazards, and cleaning and sanitizing residues are the chemical hazards. There are no physical hazards. Now let's take into consideration the step pasteurization. The biological hazards are survival of vegetative pathogens, contamination with vegetative pathogens. The chemical hazards are cleaning and sanitizing residues, allergens, boiler additives, cooling water additives. The physical hazards are none. In case of homogenization, contamination with vegetative pathogens is the biological hazard. Cleaning and sanitizing residues are the chemical hazards and the physical hazards are none. In case of packaging, the biological hazards are contamination with vegetative pathogens. The chemical hazards are cleaning and sanitizing solution residues, toxic or carcinogenic substances, and allergens. Glass is the physical hazard. In case of cold storage, contamination with vegetative pathogens and growth of pathogens are the biological hazards, while the physical and the chemical hazards are none. Let us take into consideration the HACCP plan for pasteurized milk. The hazard is microbial. The critical control point is CCPB1, which is the pasteurization temperature. The critical limit is 76 to 80 degrees Celsius for 15 seconds. The monitoring involves pasteurized milk and pasteurization temperature. The corrective action is that it is sent for repasteurization, effective monitoring, and the thermographs are studied. The verification procedure involves proper temperature control and working of pasteurizer. Again, the hazard is microbial. This time the critical control point is CCPB2. Working of UV light is the CCP here. The critical limit is the non-working of UV light. The monitoring is the working of UV light. The corrective action is reprocessing of whole lot and repair of UV light, which is a preventive maintenance method. The verification procedure is microbial load and working of UV tubes during packaging. After that, once again the hazard is microbial. The critical control point is CCPB3. The critical limit is that the temperature should be greater than 4 degrees Celsius. The monitoring is that cold storage and temperature and hygiene should be monitored. The corrective action is that effective temperature control, cold storage structure to be modified to maintain proper temperature. The verification procedure involves cold storage temperature verification. Now let's start discussing the critical limits. Pasteurization time and temperature is the critical control point 1. The critical limits are that the time and temperature should be 62.78 degrees Celsius for 30 minutes or 76 to 80 degrees Celsius for 15 seconds or 135 to 150 degrees Celsius for a fraction of a second. Working of UV light is the critical control point 2. Non-working of UV light is the critical limit. Packaged milk storage is CCP3. Cold storage temperature greater than 4 degrees Celsius is the critical limit in this case. Monitoring. First of all, we would like to talk about the monitoring of reception. In this case, what do we need to check? Visual inspection should be done, lab testing should be performed, and sampling of the incoming milk should be done. In case of record keeping, the presence or absence of contaminants should be recorded. Preheating. We need to check using thermometers and temperature sensors. We need to record the time and temperature. Filtration and clarification. We need to check regular inspection of the equipment. We need to record any resulting maintenance. Storage. Proper temperature and storage conditions should be checked and cross-contamination should be avoided. Any resulting maintenance should be recorded. Standardization. In case of standardization, proper cleaning and maintenance of equipment should be checked. Any resulting maintenance should be recorded. Pasteurization. In case of pasteurization, the monitoring procedure involves monitoring of proper temperature and holding time. Also, the regenerating section should be maintained. The temperature and time should be recorded. Homogenization. Proper cleaning and maintenance of equipment should be checked. Any resulting maintenance should be recorded. Packaging. There should be proper filling. Packaging materials used should be recorded. Cold storage. The temperature control should be checked. The temperatures should be periodically recorded. Record keeping in case of milk processing involves audit record, equipment record, product record, staff record, cleaning schedule record, customer confidence record, hazard analysis plan, and record of inspection or investigation. Thanks for watching my video.